We're good?
Yep.
Okay. All right. Apologies for the technical difficulties. Hopefully you won't see any of it. But so what ended up happening was the quotes here were no good. And I bet somebody who knows Bash really well is watching us going, why would you do that? So, but anyway, yes, I believe we've got it working now. So we're going to go ahead and start where we were before, which is job.sh. We're going to check the queue, and there it is, of course. Still a good thing. Not so much for you for having to wait, but for us. And that's the last time I'm going to make that joke. Till next video. All right. Just keep an eye on it here. Okay, there we go. 2 seconds in. So we have our job.log. And it's probably loading up Anaconda right now. Hasn't even gotten to the DMTCP. And I have to keep switching tabs to get it to refresh. So that's what I was doing that. So there you can see it's, running, got this number calculated for this number of seconds of wait time. And it keeps going. And if I refresh again, there's our checkpoint file, right? So we have this restart script and then the actual checkpoint file. So we get one checkpoint file per job run, per node with this unique identifier number, 11517, blah, 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 blah. And then each one of those image files also gets its own script. And then there's an overall script that's a little more user-friendly that calls all of those individual scripts and reloads them. That way, if it's MPI, right, when we talk about that in the future, it'll be able to put them all back onto each of the nodes, each of those images on each of the nodes. And so what I'm going to do is, now that it's run for a little while, I'm going to go ahead and, oh, you know what, we'll just let it finish. It's fine. We'll show you the other use case in just a minute. I spent too long talking. Well, not going to we'll just put an S cancel. 7, 6, 8, 0, 2, 2, 5, boom. And so we'll see in here. Oh no, it was canceled right before it finished. Something went wrong. Okay, so we're gonna I have another script. All it does is restart. And we have to set this flag, DMTCP cord host, as localhost. I'm gonna show you why real quick, because this is an important little detail. If you look through here, you'll see, where is it? Ah, yes, our coordinator host is C0065. Well, when we restart this job, we don't know that we're going to be on C0065. So we set this flag and it says, oh, if it exists, then I'll use it. Otherwise, use the one that it was on before. We don't want to use the one that was on before because we might be on C003, right? 0003 for all we know. And then it just won't work. So when we restart the job, we set this flag, then we go ahead and call that script. And so that's the only real difference between this and our job shell, right? And you could probably put that into an if-then check if you wanted to, like if this script exists, then use it, otherwise don't. But you set that up for how your use case is. This is just simple to code. So we're gonna do batch restart job.sh. Okay. And we're probably gonna be, yep, in the priority, of course. And I was savvy enough to have it named for the name of the job, so it won't override the other job script log. So there we go. And there it is. And so if we, yep. I don't, I'm going to be honest with you, I have no idea what this error is. I tried Googling it, couldn't find anything. But it does work. As you can see, it picked up from the last time it checkpointed, which must have been right around between step 88 and 89. And if I go here, well, hey, we're done. That's it. Now, I'm going to show you the interesting part by popping this over to the side, putting this here, and we're going to look at 89, 2.08, 0.47, 2.08, 0.47, 94, 94, 84, 84, right? So it saved that random number generator state. And it's just regenerating based on that same state. So you expect it to be completely deterministic. So that's how we know that it's really saving our job.
That's interesting.
Yeah, isn't that cool? I thought that was a neat little thing to show. The example I found that I based this on did it with a deterministic sequence 1, 2, 3, 4, 5. But I thought this would be more fun to show because RNG is not really random. It's pseudo-random based on some deterministic, really hard to pick apart algorithm. And so here we know that it's being repeated because computers are completely different in this case. All right. And I'm sure some folks may have questions. If you're EAB, throw them at us. Come to our office hours. Let us know. If you're not, well, you can leave them in YouTube chat and we'll try to get to you, or the comments, and we'll try to get to you. Otherwise, though, I hope this has been illuminating. That's all I've got.
Yeah, it is definitely for me. I mean, it's pretty interesting. You were able to just restart the job and it completed, and this was one of the use cases that we were mentioning, that if your job runs into any errors or something, and you just want to start from the last stage, and so like William canceled it at 97th or something in his first run, right?
Right.
And
yeah.
that was just consider that to be the limit. Like 6 days, 6 hours have passed.
Yeah.
You're getting a timeout error. So next time you run, so rather than starting from step 1, next restart is from 89th, because that's where the checkpointing happened. So it might not be exactly the last moment when it happened, but it wouldn't be very beginning as well. So yeah, that's why this DMTCP is pretty interesting. And we do have module for it, like the one that William was using. I believe there might be some newer versions out for this DMTCP, but if there are, we'll get the latest versions installed on Chiha, and please try these examples out and let us know, and try it out with your own scripts as well, your own job scripts, and if you run into any issues, definitely let us know. And like William mentioned, we are still learning, and we would like to learn together. And and you guys can be the test cases for us.
Sure. Yeah, you're guinea pigs. One thing Ravi inspired in my head was that you have to be careful choosing this interval. If it's too small, then you're going to spend all your time checkpointing, and your job will take a lot longer to run, right? Because writing to disk is not a super cheap task. And if you're running something that uses 100 gigs of RAM, right, you're writing 100 gigs of data to the CPU every 5 seconds. That's ridiculous, right? You're never going to get finished. On the other hand, you don't want to set it to too big of a value, because then you've got a really long interval to wait. So pick something that isn't too small, right? That is reasonable for your use case, right? You want it to at least be as long as 1 or 2 loops. Yeah. You don't want it to be so short that it's like, between a loop finishing, for example. So you got to think carefully, like with anything in programming, you have to think carefully about what is my goal? What is it I want to achieve? And can I maybe even experiment to figure out what's the optimum? Right?
So I have a quick question. Once it's checkpointing, does it replace the previous checkpointing image, or does it create a new checkpointing image?
That's a good question. I have not by any means explored all the options and flags available to DMTCP.
Okay.
It's possible that there is one that says, write a new checkpoint every time, but I don't know how it would handle that. That is possible. And there are use cases for that if you wanted to, track how a job's going. Over like you want to do statistics on it for some reason. But that one's also risky. What if you're doing 100 gigs and you're writing a checkpoint every hour, and you say, save them, and then it's an 100-hour job. Now you've got 10,000 gigabytes of image data, and not the image analysis image kind of data, just binary data sitting on a hard drive somewhere. And then your sysadmin's going to come to you and say, stop that.
Yeah, and to the earlier point that William was making, definitely see your use case. If your job only runs for 5 seconds, checkpointing might not be much useful in that case.
Sure.
I mean, 5 seconds, you can run another job. That's not a big deal. It's not going to take a long time.
Yeah, this isn't meant for like embarrassingly parallel tasks where you can run 10,000 5-second jobs, right? This is meant for the one where you run 5 10,000-second jobs.
All right, this was very interesting, and I hope would be very useful to our user community. Just because we know that there are a lot of long jobs in our queues generally, and they would find this to be really useful. Just if for nothing else, just for the fact that if they run into some kinds of errors, they have a checkpointed space from where they can start their jobs again.
Mhm.
And yeah, so
All right.
yeah, and like William mentioned, definitely come to our office hours or send us an email if you guys have any questions or errors when you guys are trying that out. We will post the links for the GitLab and GitHub. I think it's the same repo. It's just on both GitLab and GitHub. So we'll post both the links over here. In both those places, the repo is public, so you guys should be able to clone it and try to run these on your own.
Yep, and those will be in the description for the video. And I look forward to hearing more about your adventures with checkpointing.
Yeah.
If this is not enough for you, if you need the MPI one, then start leaning on us, right? It'll give us a reason to really push it. So. All right. Thanks, everybody.
All right. We'll talk to you guys next week when we have another